Hi, today we are on the topic of integral of trigonometric function. Now, I will not be showing you the detailed working, but I will be rather showing you which formula to use and which identity formula to use. You find that for integral of trigonometric function, these are the two most commonly used integral formula, and the other one, the last one, is by parts. And we often make use of all these trigonometric identity. Now there are more to these. There's no space, so I leave some of them out. Now let's do number one. Integral of sine cube x times cos x. Now you differentiate sine x is cos x, so you can make use of this formula. All right, so this one you use formula number 2. Now how about this? Now there's no formula to allow you to integrate sine square x, so you have to change it to a double angle, use a double angle formula. All right, so you are using this part, the third one. Okay, so this one we use the third formula. Okay, now how about this? Cotangent x can be written as cos x over sine x. Differentiate sine x, you get cos x. So the differential of the denominator, the numerator is the differential of the denominator. So this one we use number 1. Now look at this. Now this one we can make use of sine square x plus cos square x is 1. Now this one is related to the formula 1 plus tangent square x equals to secant square x. All right, you can use that formula, but from here you can derive that to that formula. Okay, so this one you use formula 6. Now how about this? This one is a bit tricky. Now if you differentiate the denominator, what do you get? You get minus 2 sine x cos x. Now minus 2 sine x cos x is minus sine 2x. So you do some adjustment, all right, you find that you can make it such that the numerator is a differential of the denominator. So this one we use formula 1. Now how about this? Now you differentiate sine x is cos x. All right, differentiate sine x is cos x. So you use formula number 2. Okay, sine to the power of 5x. This is a bit tricky. This is a bit tricky. Now you can break down into sine x, sine to the power of 4x dx. Now I will not be writing whatever these two, I will be writing just this thing here, this function. So I have sine x. Now sine square x is 1 minus cos square x. So this is 1 minus cos square x to the power of 2. And then you expand this out, you get sine x into 1 plus cos to the power of 4x minus 2 cos square x. Okay? Now then you expand further, you got sine x plus sine x cos to the power of 4x minus 2 sine x cos square x. Now you look at this, you can integrate this easily, but how about the second one? All right, this one, how do we integrate? You differentiate cos x, you get minus sine x. All right, so you differential of cos x is minus sine x. So you can make use of this formula for this part. Okay, for this particular part, you use formula 2. Okay, how about this? Now this one is the same. All right, differentiate cos x is minus sine x, so you can use formula 2 for this also. All right, so Now, so we are making use of formula 2, all right? At the same time, we use 6. So 6 and 2. 6 and 2. All right? Now, you find that if the power of sine x is odd, we always we take out one of it, and then the other one, take for example, you sine to the power of 7x. So it will be, we take out one of the term out, so sine x times sine to the power of 6x. Then we do the same thing. Same as cos. Now cos to the power of odd index. Let's say cos to the power of cube x. We take one of the cos x out, so you will be left, you will be left with cos x times cos square x. Then we change the cos square x to sine square x. Now how about this one? Now this one we can make use of the factor formula, that is for number 5. All right. You find that the multiplication of cos and sine function, if these two is not the same, all right, that means one is a one is a b, or then we can make use of this formula here, number 5, to break it up into sine p plus sine q, or sine p minus sine q. Okay. Now, if you are in doing SL math in IB, or you are doing H1 math in the A-level syllabus, this one you can leave it out, all right? So it's not in your syllabus.